Go.
In the class where we have math, we got a project that reviews what we learned here in this class that we like to call pre-calculus. We learned about the asymptote. Those are lines that cannot be crossed. They are found in different ways, such as zeroing the bottom half. The exponents also have a role to play in this graphic step. We all learned about trigonometry, trigonometry, trigonometry. We all learned about trigonometry, trigonometry, trigonometry.
Sine and cosine and tangent two are only involved with right triangle. Secant and cosecant are also there. You can't forget cotangent. These help with finding sides and angles too. We all learned about trigonometry, trigonometry, trigonometry. We all learned about trigonometry, trigonometry, trigonometry. Help, I need somebody, help, not just anybody, help. You know I need someone to find. You can find zeros by factoring. You can also use the rational zero theorem. This only shows you the possible zeros. You then must divide to find the absolute. The theorem is factors of constant over factors of the coefficient. Then you use synthetic division. Won't you please, please help me to find the zeros of a rational function? You set x to 0 for the y-intercept, and to set the numerator to 0, find the x. You know that I need zeros to graph my equation. You know factoring is very important. You need it to graph most equations. You can group or guess and check to factor. Won't you please, please help me? What would you do if I gave you a circle that went by degrees and radians? Lend me your circle and I'll show you a way to convert them easily. Oh, I get by with little help from my circle. It shows me the sine and cosine. I'm gonna try with little help from my circle. What do I do when my circle's away? I remember 30 degrees is pi over 3. Pi over 4 is 45, and pi over 6 is 60. Oh, each radian has a sine and cosine. They switch off between 1/2 and radical 3 over 2, but they are the same with radical 2 over 2. Oh, I get by with little help from my circle, little help from my circle.
Go.
Love sine is A over sine A equals B over sine B. See how they solve SSA triangles, see how they work. I'm trying, seeing if there is a possibility to have more than one triangle, or just have a triangle, or even have a triangle at all. Love sine and love cosine are used to find angles and sides. Love cosine is used for SSA squared equals b squared plus c squared minus 2 bc. Cosine A. The ambiguous case is what's used to find how many triangles would be a possibility. Maybe this helps in pre-calc, so you get all the triangles you can. Law of sine and law of cosine are used to find angles and sides.
You say exponential, I say logarithmic. Y equals b to the power of the x. Log bx equals y. Oh no. You say exponential, and I say logarithmic. B is the base. Don't know why you use the inverse of the log. Y is the exponent. It's important in pre-calc because it's used for stats.
Long and winding graph that is for polynomials will go on forever once you find the end behavior. It always depends on the leading coefficient. The exponent that is odd will go on left or right, depending if it's negative. If it is, it goes down left. If the exponent is even, it goes up or down for both. Many times the points will bounce, and many times they'll pass through. This depends on the multiplicity of the zero, and still they depend on if it's even or odd. These show us how to graph a polynomial.
X equals plus or minus b radical b to the power of 2 minus 4. ACO over 2a, and that's the quadratic formulae. You can use this in real life to help graph real life problems. We all learned about trigonometry, trigonometry, trigonometry. We all learned about trigonometry, trigonometry, trigonometry.